Hello everyone, let's solve the n repeated element in size to an array. So let's read the statement. We're given an integer array called nums with the following properties. The length of the array equals 2n, and the nums array contains n plus 1 unique elements, and exactly one element of nums is repeated n times. We need to return this element that's repeated n times. So we have an array of length, let's say 2n. And this n is the number of unique elements plus 1, and we need to find the number that's repeated n times. So let's see the example. In this example we have an array 1 2 33. The length of the array here is 4. So if it is 4, so 4 equals 2n, so the n is 2. 4 divided by 2. So if n is 2, that means we need to find the element that's repeated 2 times. In this array, the element that's repeated 2 times is 3. In this case, there's 6 elements, so the element that's we need to find the element that's repeated 3 times, and in this case, the element that's repeated 3 times is 2, so we need to return 2, and here as well. So the constraint n is up to 5 times 10 power 3, and the length of the array 2n, and every element in the array is up to 10 power 4. So what does these properties means? So first we have the 2n array. We have n plus 1 unique elements. So if we have n plus 1 unique elements, and there is one element of those n plus 1 elements that's repeated n times, so if we have a number that's repeated n times, so let's say for short, let's suppose that this number that we need to return called x. So if we have x and x, another x, let's make it just 2. So if this x repeated 2 times, so the array should have length 4. So we need another 2 elements. So here we have an array of length 4, and x is repeated 2 times, so we need to return this x. Now, the simplest solution here, we know that every other element except for x is repeated. Just the frequency of each element except x is 1, just 1, and the frequency of x is n. So we need to find the element that's repeated more than once, because any other element wouldn't be repeated any more than 1. So we just need to return x. So the simplest solution here is that we can make a frequency array or a frequency map, so that we can store the frequency of each element, and if we find one element that with frequency more than 1, so we just we will return that element and terminate the loop. So yeah, let's make it an ordered map of int and int. So if we don't know what this means, it is just it is a map of key and value pair, so that we store a value we store an element here, which is the key, and the value is the frequency of this key. So we iterate over each element on in the array. For I in nums, this array, we need to increase the frequency of this element. So map of I plus plus, we increase the frequency of this I, and if I, the frequency of I, so if the frequency of the current element is more than 1, so if it is 2, we need to return this I, and that's it. And we know that the element is repeated n times, so we know that we are for sure we will return some element of the array. We just need to return any value here, because we don't get an error, so a compilation error. So yeah, and that's it. So if we trace this example and see how this code will work, we will get to 1. We initialize the map and iterate over each element. So the 1, we increase the frequency of 1, so it be the initial value for each element is 0. when we increase the value of I, which is the 1, when we increase the map of 1, so the frequency becomes 1. Here the frequency of 2 becomes also 1, the frequency of 3 becomes 1, but here we find 3 another time, so the frequency, the before this element, the frequency of 3 was 1. We increase it again, so the frequency becomes 2, and we return this 3 right here. So yeah, and that's it. Let's run the code. Correct, submit, and yeah, accepted. So what's the time and space complexity of this solution? So the time is, we are iterating over each element of the array, so the time complexity is O of n, such that n is the length of the array, and the space complexity, here we are, the map here stores each element of the array, so the map is O of n, because we are storing each element and the frequency and its frequency in this map, so the space complexity is O of n. But here there is a better solution than this one, such that we can get rid of the space complexity of n and make it O of 1. So how can we do that? We will use the fact that we have the n, or the number x, as we said, we will call it the number x repeated n times. So the array may have multiple forms, like if we have the array of four elements, so if there is two numbers like this, that two numbers beside each other, that and x is not there, x is not one of them, so there will be one other part of the array such that there is two x's beside each other. So like this, we have four elements and two x's. So if x is not one of those, so there's one sub array or one part of the array that such that there exists more than one x in this sub array. But if there is two elements, if the total array or the whole array is like this, on this form, 1x, 2x, 3x, and so on. So let's say it's just four elements. So there's another this is valid form of the array to be. So in this case, the minimum length of a subarray such that it has x more than once is 3. This subarray has x more than once and it is 3. This was 2. So there's another form which is the maximum length of a subarray that could have x more than once, and it is like this: x, 1, 2, and other x. So this subarray of length 4 and has the element more than once. But this is the maximum subarray because there's no way we could have an array with a subarray of multiple x's and its length is bigger than this, and there's no other subarray with a smaller length such that it has x multiple times. So it is just this form or this or this. So the maximum length of those is this subarray of length 4. So how can we use this fact to remove the space complexity, to make it constant? So we just need to check from each element, from each index we have. We say that the maximum subarray that could have multiple x's is 4. So let's suppose that the array is bigger than this, so of 6 elements. So let's say 1, 2, 3, x, x, x. So this, we have a subarray of length 2. So, but if we remove this x, and here we have this, but if we can remove this from here and add it here, so here the minimum length we have 3, but we can remove this x and add it here. We have this subarray of length 4. There's no other way that we can separate these two x's from each other such that the length between them is more than 2. So that means the maximum length that we could have such that x exists more than once is just 4. So we need just to check for I equals 0, I is less than n and I plus plus. We need to check for each subarray of length 2 and 3 and 4 if there is more than one x in this subarray. So here we will pick 4 elements and check compare this with this. If they are equal, we just need to return the value and compare this with this. So that means we compare the subarray of size 3. If this one equals this, so we return this and compare this with a subarray of length 4. We compare the one with 3 and return it if it's valid, and that's it. So if I plus 1 is less than n, we need to check for each index after the current index because we don't get a runtime error. So and nums of I plus 1 equals nums of I. So if there's an element after me and it's equal to me, we just need to return the value of this element, nums of I. So if I plus 2, the same for I plus 2 and I plus 3, we can make it like this, I plus 2, and the same for I plus 3. Yeah, and that's it. We check for each subarray or each part of size 2 if the x exists more than once, and for each part of size 3 and for each part of size 4. And we said that there is no way we can get a subarray of length more than 4 such that x exists more than once and there is no smaller subarray. So yeah, this is the code, and here we should return anything because we don't get a compilation error. So yeah, this is the solution. We can remove this now and try it. Oh, we didn't have n, so num, let's initialize n equals nums.size. Run it. Yeah, correct. Submit and accept it. Yeah, and that's it. As we said, the time complexity is here is of n because we are iterating over each element, but the space complexity, there's no space. The space complexity is constant because we're not storing any element in an array or a map or anything. So yeah, let's write it. The time is O of n, and the space is O of 1. And that's it. Thanks for watching. Peace.